before things are that accurate? Or like, you know, how inaccurate are the ones that are just stamped?
I leave that to you. No, realize that when you're dealing with error in experimentation, it's fine to have error, but if there's any way that you can document it. So when you're looking at a tuning fork and there's a 320 on it, and you haven't taken any measurement to validate that, it's kind of left up to the whim of, oh, I think it's right. So that's why, and last period, students had this on their phone within like 60 seconds of starting the lab, and we're checking the frequencies. I'm doing this just because there are a couple of things to point out that will get you moving along a little more quickly. First thing is you want to have the water basically almost to the top of your resonating column, i.e. the PVC pipe. And then, when you strike a tuning fork, realize that the energy dissipates fairly quickly. So you want to try to target that air column length pretty quickly. So I start by pulling things up pretty fast until I hear that first sound. Then I do it again, kind of tune it. So that's where I call it good. And so you'll have a partner take that measurement. Notice this is a 518. You need that much air column. 1,000, which is twice the frequency, is going to need much less. So just be aware of that. It's also the 1,000 is a little harder to hear. So that's where it is there. But you're going to be doing this lab with about 10 or 12 other groups. So you're welcome if you need to go out in the hall to get some silence. Just to hear that, that's fine. All right, so the goal is that you get your data collected, and you get it all into tables, get your data graphed, and into a report, ideally by the end of the class. Okay, so the tubes, tuning forks are back there. Take water from the two sinks. Here's some of the water containers.
So you want to get a ruler?
Hey, can we use you guys? Hey, are you guys using the? Hey, are you using the roller?
We're like in the middle of this, right?
Hey, are you using the roller though?
No, this is why it's heat. There's like rulers over there. Sorry.
Okay.
Let's just see what this looks like. Insert. Oh right, I forgot. Yeah, we're supposed to put one over. I think it's 1 over weight. Yeah, 1 over weight. Okay, 1 over weight.
No, we're done. We're done. Yeah. Also, we have
Divided by... No. Oh right, I forgot. Yeah, look at this. Divided by 20. Nope, that is still reading it as...
You got a different one that's smaller.
Sure. Equals...
Yep.
Is 1.5. Nope. Function. Let's see. Sum average.
No, I'm just gonna fight. Start finding Johnson and start driving that.
strange. Okay,
And it's like, at first she was just like, take pictures of that.
Oh, and the other thing is, did you measure your night? Air calls, did you multiply that by 4?
oh, right, yeah, because it's supposed to be the whole way.
Then you also know that the slope there is
People pay for this if you make it bigger. Like, we actually
or you just simply say that in the report and take that value and invert it.
All the labs we do are very hands-on instead of like teaching out of a textbook. I mean, we really rarely have like worksheets or like bookwork, so that's nice.
Why is that better for you?
I don't know. I guess in your mind you like learn it a little better versus like just listening or something. It sticks with you a lot more because you're able to do it by yourself.
Has this been a little frustrating for you doing this lab? I've been watching you a little bit. It's been
Yeah.
a little frustrating, right?
It's a little hard to hear this stuff.
Yeah. So what does that do for you, though? I mean, as a learner? It's frustrating, though, right?
Yeah, I mean it's part of our grade, so it's not like we can't just like give up or anything.
Good, great.
So are we timesing lambda, the wavelength by 4 or L by 4? So whatever we measured, we times that by 4 to get the wavelength.
Oh, whoops, I did that. You're being very sassy. It's really annoying.
This is frustrating me.
I got mixed up.
Why is it frustrating you?
Just labs in general frustrate me.
Why?
Well, I don't know. I mean, there's not like a lot of instruction. It is. I don't know. I'm contradicting what I said before.
That's okay, don't worry. Is it frustrating to kind of do it this way? Like, did you have to redo some things or things mess up?
Yeah. To get like the graph right, but that was like our error. So.
Oh, right there.
I don't know.
That's not right. Try linear again. No,
Aha! Horizontal axis.
Are you looking at my graph?
Their graph is completely different.
That's
What
because
did you guys do?
That's crazy.
You can ask him.
Dylan, what did you guys do?
They just put down the frequency and distance.
Okay, now you need to multiply and divide the distance by 1.
Like this.
Yeah.
And then solve that. Okay. Wait, multiply by 1?
And divide it by
How comfortable did you feel in this activity with the responsibility resting mostly on the students today?
I felt very comfortable. We've done an activity where the responsibility rests on us a lot before in this class, and so it was fairly comfortable because I also know that Mr. Schlichting could answer any questions that come up with problems with the equipment.
In order for the lesson to be more valuable to you, what do you need the teacher to do?
I believe that in order for the lesson to be more valuable, an introduction to the lesson and the equipment is very valuable, especially in a science class.
What were you doing during most of the time that you were working independently? What were your actions?
So I started out with collecting a bunch of data, which probably took up about like the first half of class. And then I was working on my computer with a lab report, which is just typing up and computing data.
What was the teacher doing during most of the time?
He was walking around and answering questions, and he actually double-checked my data at one point to make sure I didn't have to collect any more.
What do you think the goal of today's lesson was?
The goal of the lesson was to, first of all, make sure that we understood the principles behind the theory we were testing, and second of all, we have to do a lab report for IB, so we had to get that out of the way.
Do you think that the goal was achieved better because you were working sort of on your own?
Yeah, yes, I definitely think the ideas and the goal kind of cemented more in my brain because I was able to struggle with the material a little bit personally.
So one of the things that Mr. Schlichting's group is focusing on is calling it sort of student-centered learning. Do you think that this science class today is an example of sort of student-centered learning? And if so, how can that be applicable to other disciplines?
So I think it's definitely a example of student-centered learning because it was very minimal teacher help and it was a lot of just personal researching and collecting. I think some subjects can benefit greatly from this and others don't really. I mean, history a lot of times is just a lot of learning and memorizing, so I think it's more, it has to be kind of led by a teacher, but classes like a language and sciences could really be student-based.
Is it better for you as a learner to have it more student-centered?
You know, I actually do a lot of good learning with student-centered, especially with physics, and I also take biology, and that's kind of student-centered. Language, it's a little bit harder, but I think it could benefit from being student-centered because then it could be more individualized.